welcome to this explainer. If you've been wondering how we're going to secure our global food supply against these crazy, increasingly harsh weather patterns, well, you are absolutely in the right place. Today, we're unpacking the El-Nino Irrigation Optimizer. This is a genuinely fascinating application that essentially stacks modern technology to conserve water and maximize crop yields during severe droughts. We're going to look at the exact mechanics of this app today, going all the way from ground-level sensors right up to the artificial intelligence running the whole show.
So let's just quickly glance at our roadmap for today. We'll start with the El-Nino Crisis, move into hyper-local telemetry zones, and then precision AI irrigation. After that, we'll take to the skies with drones and nano-urea, step into the Synergy Lab, and wrap it all up with a precision science action plan. All right, let's climb this tech stack.
Okay, part one, the El-Nino Crisis. We've got to establish the intense threat of extreme El Nino droughts first, because they are quite literally devastating traditional farming methods. It really comes down to this core problem: speculative watering versus high-precision science. Speculative watering is basically just old-school guesswork. You look at the field, you kind of guess what it needs, and you apply broad, inefficient amounts of water. But when you're facing an extreme El Nino drought, that kind of guessing just leads to massive water waste and failing crops. On the flip side, we have the urgent necessity of high-precision science. The Optimizer app is completely built around making this exact pivot, abandoning that hope-based farming for hyper-efficient, data-driven resource management. Moving right along to part two, hyper-local telemetry zones. So this is where the app really meets the dirt, so to speak. When you add a specific crop, say grapes or almonds, into the app, you aren't just dropping a static pin on a map. You're actually provisioning a live interactive zone. It continually monitors three main environmental triggers: moisture levels, wind speed, and the solar index. And what's super cool here is the live demonstration capability. You can actually adjust telemetry sliders for these exact metrics, and the app simulates and responds to real stress alarms right there on a hyper-local level. It's kind of like having a digital twin of an orchard, where you can see exactly how a sudden spike in the solar index combined with high winds triggers an immediate localized stress alarm. You're seeing the invisible threats before the damage is even done. All right, part three, precision AI irrigation. Let's step up to the brain of the operation, the Gemini AI advisory engine. Here is the exact step-by-step process of how it takes control. First, the AI is constantly analyzing that hyperlocal field telemetry we just talked about, crunching all that moisture, wind, and solar data in real time. Second, instead of just cranking on a massive sprinkler system, it meticulously plans night cycle microdrips. Now, why the night shift? Well, because it completely bypasses daytime sun evaporation. Seriously, in an extreme El Nino drought, watering during the day is essentially just watering the sky. Total waste. Finally, it executes what's known as a virtual water cycle. It delivers the exact microscopic amount of water needed, right on time, with zero waste. It's an incredibly clever, completely autonomous survival mechanism for the crops. Part 4. Drones and nano-urea. Now we take to the skies. What exactly are these autonomous drones spraying? It's called nano-urea. This is a highly efficient, leaf-absorbing mist applied to specifically target and fix nitrogen deficits. The app uses multispectral drone scanning to look down at the crop and identify exactly which plants are starving for nitrogen. When the drone scans spot a deficit, boom, the app triggers the spraying of the specialized nano-urea mist. It doesn't blindly spray the whole field, it only hits the exact areas that are sounding the alarm. The crucial takeaway here is this sharp contrast. We are completely replacing wasteful, heavy soil fertilizers with targeted aerial mists. I mean, traditional farming just dumps heavy fertilizer onto the dirt, crossing its fingers that it reaches the roots. But that just causes massive runoff, and it's incredibly inefficient. The Optimizer app flips the script entirely. By using that leaf-absorbing nano-urea mist, the nitrogen is taken up directly by the plant's foliage, exactly where it's needed. It drastically improves efficiency and ensures that vital nutrients aren't just lost in the dry, drought-stricken soil. Okay, part 5, the Synergy Lab. Now, this is where the magic really starts to compound. The Synergy Lab is an interactive canvas where farmers can literally toggle on biological hacks. We're talking hydrogels to retain soil moisture, mycorrhizal fungi to expand root absorption, and actual sap sensors for real-time internal plant feedback. Think about it. When you combine the water-holding power of those hydrogels, the supercharged root absorption from the fungi, and the live feedback from the sap sensors, you don't just get a small linear bump. Farmers trigger a massive exponential compounding effect on their water savings. Stacking these biological tools alongside the AI and the drones creates a nearly drought-proof environment. So what's the ultimate result of stacking all this tech? a 2 times multiplier, as tracked by the app's dynamic financial gain counter. Using this whole stack of microdrips, AI planning, drone spraying, and biological toggles can effectively double a farmer's seasonal yield, even under extreme El Nino conditions. I mean, doubling your yields during a severe drought? That is huge. That's literally the difference between losing the family farm and completely thriving. And that financial gain counter makes this super practical, showing farmers the direct monetary benefit of precision science in real time. Finally, Part 6, Precision Science Action Plan. The entire goal of the El Nino Irrigation Optimizer boils down to empowering farmers to make that exact transition from speculative watering right into high-precision science. It provides a direct, comprehensive pathway away from the era of guesswork. By integrating the telemetry, the Gemini AI, those autonomous drones spraying nanourea, and that incredible compounding biological tech in the Synergy Lab, the app isn't just a tool, it's a complete paradigm shift for modern agriculture. As we wrap up this explainer, I want to leave you with one absolutely crucial question to think about. Is our food supply chain relying on yesterday's guesswork or tomorrow's precision science? The answer to that is going to determine the entire future of global agriculture. Thank you so much for joining me to unpack the fascinating mechanics behind the El Nino Irrigation Optimizer. Keep learning, keep asking questions, and I'll catch you in the next explainer.